Welcome. Today's discussion is about digital twins, a game-changing innovation allowing us to create virtual models of stores, factories, or entire supply chains. These digital replicas update with real-world data in real time, letting businesses experiment and refine operations in a safe virtual space before implementing changes on the ground. From optimizing a single store's layout to simulating a global supply chain, digital twins are revolutionizing how we plan and execute strategy. As a leader in AI-driven consulting, HI-GTM is at the forefront of guiding businesses to leverage this transformative technology. In simple terms, a digital twin is an exact digital replica of something in the physical world, whether it's a piece of equipment, a store, or even an entire logistics network. This isn't a static model, it's fueled by real-time data. For example, sensors on a production line feed live data into its digital twin, so the virtual model reflects every change instantly. Why does this matter? Because it gives us a decision simulator. We can test what-if scenarios in this virtual environment, adjusting a process, reorganizing a warehouse, and see the outcome before we commit resources in real life. It's like having a crystal ball for business decisions, greatly increasing our certainty and reducing risk. Let's talk about how it works. First, data collection. Physical operations are instrumented with IoT sensors, capturing everything from equipment performance and inventory levels to customer movements in a store. This data feeds into a digital model, your twin, which simulates the process or environment with remarkable accuracy. Advanced simulation software and algorithms, often powered by AI, allow us to tweak variables and run scenarios. For instance, we can virtually increase production speed on a factory line to see if bottlenecks occur, or reroute a delivery network in response to a hypothetical port closure. The digital twin will show the effects. Then comes the feedback loop. If the simulation identifies a better configuration, managers can implement that change in the real world. Conversely, any real change, say a new piece of equipment, updates the twin. This tight integration means the twin and the physical system continuously inform each other, driving ongoing optimization. Several tech giants have invested heavily in digital twin technology. Siemens, for example, offers MindSphere, an industrial IoT ecosystem that connects machines and systems into digital twins. They've used it to significantly boost factory efficiency and product quality. GE Digital has Predix, known for modeling complex equipment like jet engines or power turbines. It helps predict failures before they happen by simulating wear and performance. IBM provides twin solutions through its Maximo and Watson IoT platforms, layering AI to monitor everything from building HVAC systems to hospital equipment. Microsoft's Azure Digital Twins leverages the cloud to create live digital models of physical spaces. Imagine managing an entire smart building or even a city's infrastructure virtually. Other notable players include PTC's ThingWorx, which blends IoT data with augmented reality for hands-on insights. Oracle's IoT cloud services, which have been used to twin logistics networks and streamline supply chains, and Ansys Twin Builder, excelling in high-fidelity engineering simulations. The takeaway, the ecosystem is rich, and choosing the right partner depends on your industry and goals. HI-GTM can help navigate these options, ensuring you pick a solution that fits your strategic needs. Artificial intelligence is the engine that supercharges digital twins. Traditional simulations are powerful, but AI-driven twins take it further by learning and improving continuously. With predictive analytics, a twin can analyze patterns. For instance, it might predict a spike in retail store traffic this weekend based on weather and past data, or foresee when a factory robot will need maintenance by analyzing vibration patterns. AI also enables autonomous optimization. The twin doesn't just wait for humans to ask what if, it can itself run thousands of scenario variations, adjusting schedules, routes, layouts, to find the best outcome and then recommend that action. Generative AI is the latest frontier. Imagine an AI that can dream up and test countless plausible scenarios that humans might not even think of. For example, it could simulate how a supply chain responds to every conceivable disruption, or how tweaking a product design might impact performance, all in parallel. The more the system operates, the more it learns from each success or failure, continuously sharpening its predictive accuracy. This AI-infused approach means digital twins become not just reflective models, but proactive advisors, guiding us to decisions that preempt problems and seize opportunities. With great data comes great responsibility. Digital twins thrive on data, some of which can be sensitive, like customer purchase patterns or detailed operational metrics that could be proprietary. Compliance with data privacy laws is non-negotiable. In Europe, the GDPR mandates strict rules on how personal data is collected and used. If our retail digital twin analyzes in-store video to model customer behavior, we must ensure we have consent and that we're only using the data we truly need, data minimization. California's CCPA similarly gives consumers rights over their data. For industries like healthcare, if we had a digital twin of a hospital or even a patient for personalized medicine, HI-GTM laws kick in to protect health information. Failing to comply can lead to multi-million-dollar fines or legal action. Security is equally critical. A digital twin that's connected to your live operations could be a target for cyber attacks. We have to design twins with security in mind. Encrypt data in transit and at rest. Use strong authentication, like multi-factor login, so only authorized staff access the twin and segment networks to contain any breach. Regular audits and penetration tests are wise, and importantly, where feasible, we anonymize personal data. For example, our digital customer models might use behavior data without attaching names or IDs. By embedding compliance and security into the digital twin strategy from day one, HI-GTM ensures our clients not only innovate fast, but also uphold the trust of customers and partners while meeting all legal obligations. Retail is leveraging digital twins in exciting ways. Think of a store layout optimization twin, an exact digital replica of a store where we can rearrange products on screen and immediately see how it affects customer flow and buying patterns. One apparel retailer did this to decide an optimal layout for a flagship store. The twin predicted a 5% sales uptick by simply moving certain displays, and indeed the real store saw similar gains after implementing those changes. It's a powerful way to take the guesswork out of merchandising. On the operations side, inventory and warehouse twins are reducing carrying costs. By simulating inventory levels across a network of warehouses and stores, a twin can forecast demand surges and adjust stock accordingly. For example, if the twin foresees a spike in winter coat sales in New York next month, it might prompt managers to redistribute inventory from other regions proactively. This means fewer stockouts and less excess stock collecting dust. Perhaps the most novel is modeling the customer behavior. Using data from loyalty programs, in-store sensors, and online interactions, retailers can maintain a virtual profile or twin of their customer segments. This isn't a static profile. It's continuously updated with new data. By running simulations, say, if we introduce a 20% off coupon on running shoes, how will this customer segment respond? The twin helps marketers personalize offers. Nike, for instance, analyzes customers' purchase history through digital models to tailor recommendations in real time. The result is a shopping experience where customers feel the brand really knows them, and it drives loyalty and sales. In short, from the sales floor to the stockroom to individualized marketing, digital twins are enabling data-driven decisions in retail with less risk and more reward. In manufacturing, the motto has become simulate first, build second. Consider production line simulation. Before reconfiguring an assembly line or adding a new robot, engineers clone the entire production process into a digital twin. They can experiment with different assembly sequences, machine speeds, or even factory layouts in this virtual plant. One automotive company used a digital twin to simulate a new assembly method for electric vehicles. They discovered in simulation that a particular station would become a bottleneck at higher volumes, so they fixed the issue in the model and then implemented the optimized process in the actual factory. The result was a 15% throughput improvement, with minimal disruption on the shop floor because the debugging happened in the twin. Another huge win is predictive maintenance. Each machine, a press, a turbine, a conveyor, can stream data to its twin. The twin, armed with machine learning, learns the machine's normal patterns and can alert maintenance teams of anomalies. Machine number 5's motor vibration is 20% above normal, likely to fail in 10 days. This way, you schedule a fix during planned downtime before a breakage forces an emergency halt. GE and Siemens have applied this to jet engines and industrial turbines, saving millions by preventing unplanned outages. Even in product design, digital twins shine. Engineers can subject a digital twin of a new product to virtual stress tests, heat, pressure, fatigue, using simulation software, ANSYS for instance, rather than costly physical prototypes. Only the most promising designs move to physical testing, accelerating R&D cycles. Quality and consistency also improve. By simulating slight variations in raw materials or environmental conditions, the twin can help adjust the process to maintain output quality. All told, manufacturing twins lead to faster innovation, lower costs, fewer physical trials, less downtime, and superior quality control, exactly what every plant manager or COO wants. Supply chain and logistics might be the ultimate playground for digital twins, because these systems are so complex and vital. Let's start with the big picture. An end-to-end supply chain twin. Imagine a control tower view where your entire supply chain, every supplier, every transit route, every warehouse, every store, lives as a digital model. Now imagine a typhoon knocking out a key supplier in Asia. Instead of reacting in panic, your digital twin has already tested this scenario. It might tell you, if supplier A goes down, supplier B and C can cover demand for 3 weeks, but you'll need air freight instead of ocean shipping to avoid stockouts in stores XYZ. This kind of resilience testing means no more scrambling. You have a playbook ready. Companies are using twins to run war game scenarios, natural disasters, transport strikes, sudden demand spikes, so they can identify weak links and bolster them in advance. It's about making the supply chain shock-proof. Drilling down, warehouse operations benefit too. In a warehouse twin, you can rearrange racks, change how picking robots navigate, or simulate different staffing levels during peak season. Perhaps the twin shows that by placing the 100 top-selling items closer to the packing station, you cut average picking time by 30%. You implement that change in the real DC and immediately see faster throughput. Twins can even tie into systems like autonomous guided vehicles, AGVs, or robotics in warehouses to fine-tune their paths and coordination. NVIDIA, for example, has developed digital twin simulations for warehouse robotics to ensure they move efficiently without collisions. On the logistics and delivery front, the daily challenge is routing and scheduling. A twin of your logistics network can ingest live traffic data, weather forecasts, and delivery constraints, then churn through scenarios to find the optimal routes. UPS famously uses an AI-driven system to minimize left turns to save fuel. A digital twin takes that further by simulating entire route networks for best outcomes. Oracle's IoT platform has helped some firms do exactly this, leading to improved delivery times and lower transport costs. One retailer's twin might even simulate customer demand by geography, helping reposition inventory closer to hotspots ahead of time. In conclusion, digital twins allow us, as business leaders, to navigate uncertainty with far more certainty. We can rehearse the future before we live it, whether that's a new store format, a factory upgrade, or a supply chain pivot. The ROI is tangible. Companies using digital twins have slashed operational costs by catching problems early and optimizing processes continuously. Think of it: fewer production stoppages, leaner inventories, happier customers because you get things right the first time. That's a serious competitive edge in today's fast-moving markets. The question now is not can we afford to implement digital twins, but rather, can we afford not to? Businesses that stick to guesswork and reactive changes will fall behind those running high-fidelity simulations and proactive adjustments. This is where HI-GTM comes in. Our expertise in AI-driven consulting means we understand both the technology and the business strategy needed to fully leverage digital twins. We help you identify the most impactful twin opportunities in your operations. Select the right platforms, whether it's Siemens, GE, IBM, or others, and ensure data governance and security are ironclad. We'll work with your team from concept to full deployment and ensure you reap measurable benefits quickly. Take the next step. Reach out to us at HI-GTM.com for a consultation. Together, we'll simulate your next big move and then make it a reality with confidence. The future is here, in twin form, and we're excited to help you lead in this new era of data-driven innovation. Thank you.